Hello everyone. Before we proceed with the matrix from visual representation of transformation, let us answer first the practice problems that I have given you on the last video. So on the first problem, we are going to see where the point at -1, 0 end up after the plane has undergone the transformation. So if your answer is at -1 and 2, then your answer is correct. In the second practice problem, you're going to predict where the point 3, 0 will land. So if your answer is at 3, -6, once again, you are correct. In general, each vector xy can be broken down as follows. So the vector xy is equal to x times the vector 1, 0 plus y times the vector 0, 1. We are using 1, 0 and 0, 1 because this is the standard basis of vectors. So if the green arrow 1, 0 lands on some vector AC and the red arrow 0, 1 lands on some vector BD, then the vector xy must land on x times AC plus y times BD. And that is also the same as ax plus by, cx plus dy. So in this matrix above, the first column tells us where 1, 0 lands, that's AC, and the second column tells us where 0, 1 lands, that's BD. We can describe where any vector xy lands very compactly as the matrix vector product. So vector AB is equal to ax plus by, cx plus dy. Now let's proceed with the matrix from visual representation of transformation. Let us have a warm-up example. So for instance, suppose we want to find a matrix which corresponds with a 90-degree rotation. So this is the 90-degree rotation. So the first column of the matrix, as what I have said a while back, tells us where the vector 1, 0 goes. And looking at the animation, we see that this vector lands on 0, 1. So based on this knowledge, we start filling in our matrix like this. And for the second column, we are asked where the vector 0, 1 lands. So rotating this upward facing vector 90 degrees yields a leftward facing arrow. So for example, the vector -1, 0. So we can finish writing our matrix as 0, 1 and -1, 0. This is where 1, 0 and 0, 1 lands after the transformation. So let's have a problem 1. What matrix corresponds with the following transformation? So I'm going to show you the transformation and we will find out the matrix that corresponds with that transformation. So here's the transformation. So this time I will give you choices. So if your answer is C, that is 1, 0.5, 0.51, then you selected the right answer. In problem 2, what matrix corresponds with the following transformation? So here's the transformation. So from these choices, if your answer is 0, 1, 1, 0, then your answer is correct. Note that this is just a simple introduction on linear transformation before we proceed on deeper ideas. So for your activity, answer these 2 practice problems. Number 1, draw the transformation of the matrix from 1, 0, 0, 1 to -1, 0, 0, -1. Of course, we have done with identifying the matrix based from the transformation. So this time, let's reverse it. And for number 2, draw the transformation of the matrix from 1, 0, 0, 1 to -2, -1, 0, -1.